At the heart of this operation is a transformation that feels almost unbelievable the first time you see it happen. What begins as raw, heavy, spiky jackfruit, a fruit most people associate with tropical desserts or street markets, is systematically turned into something that looks, feels and behaves like pulled pork, all at a scale of 50,000 pounds per day. This transformation is not driven by illusion or artificial chemistry, but by an intimate understanding of plant structure combined with industrial precision. The journey from whole fruit to meat, like texture, is the foundation of modern vegan pork production, and every step is designed to respect the natural fibers of the jackfruit while reshaping them into a familiar culinary form. The process starts long before any machine switches on. It begins in the fields where jackfruit is harvested young, before it ripens and turns sweet. At this stage, the fruit's flesh is firm, fibrous, and neutral in flavor. Those fibers are the key. Unlike many fruits that soften into pulp, young jackfruit contains long, stringy cellulose strands arranged in a way that, when separated correctly, closely resemble the muscle fibers found in slow, cooked meat. This natural architecture is what makes jackfruit uniquely suited for savory applications, and it's the reason it has become such a powerful base for plant-based pork alternatives. When truckloads of jackfruit arrive at the plant, the scale immediately becomes apparent. Mountains of fruit roll onto the factory floor, each piece rugged and armored with thick green skin. Despite their rough appearance, these fruits are handled with care. Conveyor systems are calibrated to support their weight evenly, preventing bruising or premature fiber damage. Advanced scanners inspect each jackfruit in motion, checking size density and surface condition. This isn't just about appearance. Internal fiber quality can often be predicted from these external indicators, allowing the system to maintain consistency before processing even begins. Washing is the first physical interaction between fruit and machine, and it's more important than it looks. High-pressure water jets rotate each jackfruit slowly, stripping away dirt, sap, and microorganisms collected during harvest and transport. The rotation is deliberate. By spinning the fruit rather than blasting it in one fixed position, the system ensures that every groove in the spiky skin is cleaned without stressing the internal flesh. Clean fruit behaves more predictably during cutting, which directly affects the quality of the fibers later on. Once washed, the jackfruit enters the cutting stage, where the toughest barrier is removed. The outer skin of a jackfruit is thick, rubbery, and resilient, designed by nature to protect the interior from pests and weather. Industrial blades descend with precise force, slicing through the skin cleanly without crushing the flesh underneath. This precision matters. Crushing would break fibers prematurely, shortening them and compromising the final texture. Instead, the skin peels away in large sections, revealing the pale, fibrous interior that will soon become the star of the process. Inside the fruit, the core and seeds are separated next. These components are valuable in their own right, and are often diverted for other food or industrial uses. But for vegan pork production, the focus remains on the surrounding fibrous flesh. This flesh is dense, layered, and surprisingly structured. At this stage, it still looks nothing like meat. It's bulky, uneven, and clearly plant-based. The transformation happens in what comes next. The shredding stage is where raw jackfruit truly begins to resemble pulled pork. Large stainless steel shredders grip the fruit sections and apply controlled tearing forces rather than blunt chopping. This distinction is critical. Chopping would produce short, broken pieces, more like minced vegetables. Tearing, on the other hand, follows the natural grain of the fibers. As the drums rotate, the jackfruit is pulled apart along its internal seams, unraveling into long strands. Watching it in motion is hypnotic, solid chunks slowly surrendering to the machine, emerging as soft ribbons that pile up and flow forward like cooked meat. Maintaining fiber length is a constant challenge at this scale. The larger the operation, the easier it is for consistency to slip. To prevent this, sensors monitor resistance during shredding. If the machine detects that fibers are tearing too easily or resisting too much, it adjusts pressure and speed in real time. Temperature is also controlled carefully. Heat softens plant fibers, but too much heat at this stage would weaken them, causing the strands to collapse. By keeping conditions stable, the system preserves the integrity of each shred. As the shredded jackfruit accumulates, the resemblance to pulled pork becomes unmistakable. The strands vary slightly in thickness, just like real meat fibers, and they clump together naturally. This variability is important. Perfect uniformity would feel artificial to the human palate. Instead, controlled variation gives the final product a more authentic bite and mouthfeel. Chefs and food scientists often describe this stage as the structural mirror, where the plant finally reflects the texture people expect from pork. What's remarkable is that this transformation happens without any binding agents or restructuring molds. There's no extrusion forcing the product into shape, no synthetic scaffolding holding it together. The structure comes entirely from the fruit itself, revealed rather than imposed. This is why jackfruit-based vegan pork shreds and pulls apart so convincingly when cooked. The fibers don't just look like meat, they behave like it because, structurally, they share similar physical principles. Scaling this process to 50,000 pounds a day introduces challenges far beyond texture alone. Time becomes a factor. Freshly shredded jackfruit must move efficiently to the next stage to prevent oxidation and moisture loss. Conveyor belts are synchronized so that the flow never stops, yet never rushes. Pauses are calculated, not accidental. The entire system operates like a living organism, responding to subtle changes in input and adjusting output accordingly. Another critical aspect of this transformation is waste management. Jackfruit large and not every part becomes vegan pork. Skins, cores, and seeds are separated cleanly to avoid contaminating the fibers. These byproducts don't end up discarded. They're redirected into secondary processing streams, often becoming ingredients for other foods, animal feed, or industrial materials. This closed-loop approach ensures that scaling up production doesn't mean scaling up waste. The result of all this precision is a base ingredient that is deceptively simple. At this point in the process, the shredded jackfruit is still mild in flavor, almost neutral. That neutrality is intentional. It allows the fibers to absorb flavors later without conflict, much like unseasoned meat. But even without seasoning, the texture alone tells the story. The shreds bend, tear, and compress under pressure, responding in ways that feel familiar to anyone who has handled cooked pork. This stage represents more than just a technical achievement. It's a philosophical shift in how food is made. Instead of forcing plants to imitate meat through heavy processing, the process reveals what plants already offer when handled correctly. Jackfruit doesn't pretend to be pork. It becomes pork-like because its natural structure allows it to do so. Technology here acts as a translator, converting raw plant material into a form that fits modern culinary expectations without erasing its origin. By the time the shredded jackfruit leaves this phase of production, the foundation of vegan pork is complete. Flavor, aroma, and finishing touches will come later, but the most important work has already been done. Texture is everything in meat alternatives, and achieving it at industrial scale is what separates novelty products from staples. This is where the line is crossed, from experimental plant-based food to reliable, repeatable protein production. In this transformation, there's something deeply symbolic. A fruit grown on trees in tropical climates is reimagined through engineering and insight, becoming a staple for entirely different cuisines and cultures. It's not about replacing meat out of necessity alone, but about expanding what food can be. The journey from raw jackfruit to meat, like texture, proves that the future of protein doesn't have to be synthetic or unfamiliar. Sometimes, it's been hanging from a tree all along, waiting for the right process to unlock its potential. Once the jackfruit has been transformed into long, convincing, pork-like fibers, the process enters its most mesmerizing phase, the point where technology, timing, and sensory science converge. This is where neutral plant structure is turned into something deeply savory, aromatic, and emotionally familiar. The hypnotic precision of high-tech shredding has already laid the foundation, but flavor infusion and texture refinement are what elevate those fibers from a clever substitute into a true culinary experience. At industrial scale, this transformation is not left to chance. Every movement, every degree of heat, and every second of contact is calculated. The shredded jackfruit arrives at this stage as a blank canvas. Its fibers are intact, moist, and structurally sound, but intentionally mild in taste. This neutrality is crucial. Strong natural flavors at this point would limit versatility and create inconsistencies across batches. Instead, the production system is designed to build flavor gradually, layer by layer, allowing the fibers to absorb and retain seasoning the same way animal muscle absorbs marinades during slow cooking. The first step in this phase is controlled blending. Massive stainless steel mixing vessels receive the shredded jackfruit in continuous flow. These are not simple mixers. They are engineered environments where motion, pressure, and exposure are finely tuned. Inside, oversized paddles rotate in slow, deliberate arcs, lifting and folding the fibers rather than chopping or compressing them. This folding action is key. It ensures even distribution of seasoning, while preserving fiber length and orientation. The goal is uniformity without uniformity, every strand coated, but not every strand identical. Flavor infusion begins with a carefully formulated seasoning base. This typically includes salt for structure and moisture control, natural smoke flavors for depth, fermented plant extracts for umami, and subtle sweetness to balance acidity. Plant-based fats are added at this stage as well, often in liquid or semi-emulsified form. These fats play a dual role. They carry flavor compounds deep into the fibers, and they recreate the lubricity and richness associated with pork fat. Without them, the final product would feel dry, no matter how well it was seasoned. As ingredients are introduced, sensors embedded in the mixing vessels monitor resistance and torque. These readings reveal how the fibers are responding. If the mixture becomes too stiff, it suggests insufficient fat or moisture. If it loosens too much, the fibers risk breaking down. The system makes real-time adjustments, altering paddle speed or ingredient flow to maintain optimal texture. This constant feedback loop is one of the most advanced aspects of modern vegan pork production. It replaces intuition with data, but the result still feels deeply human. The hypnotic quality of this stage comes from its rhythm. Fibers rise and fall, seasoning disperses in slow waves, and steam begins to form as friction gently warms the mixture. The visual effect is almost meditative, a continuous folding motion that feels more like careful cooking than industrial processing. This is intentional. Sudden movements or aggressive mixing would tear fibers and create mush. The slow, steady pace respects the material, allowing the jackfruit to remain the star of the show. Once the initial infusion is complete, the product moves into texture, setting through controlled heat. Steam tunnels or thermal chambers expose the seasoned fibers to precise temperatures for carefully measured durations. Heat activates binding properties within the plant fibers and melts the added fats, allowing them to coat each strand evenly. This step locks flavor into the structure rather than leaving it on the surface. It's the difference between something that tastes seasoned on the outside and something that tastes rich all the way through. Temperature control here is unforgiving. A few degrees too high and the fibers soften excessively, losing their pull. Too low and the seasoning fails to integrate, leaving pockets of blandness. Advanced thermal sensors and infrared monitoring ensure that heat penetrates evenly, regardless of batch size or flow rate. The system compensates automatically for fluctuations, maintaining consistency across tens of thousands of pounds. As the product emerges from heat treatment, its aroma changes dramatically. What once smelled faintly vegetal now carries notes of smoke, savory depth and warmth. This sensory shift is no accident. Flavor scientists design the seasoning profile to trigger the same aromatic cues people associate with slow-cooked pork, cues that activate memory and expectation before the food even reaches the mouth. Smell becomes a powerful ally in convincing the brain that this is more than fruit. Texture is evaluated continuously throughout this phase. Samples are pulled from the line and tested for fiber length, elasticity, and moisture retention. Trained technicians stretch, compress, and tear the fibers by hand, mimicking how a consumer would interact with the product while cooking or eating. These tactile tests complement digital measurements, ensuring that numbers translate into real-world experience. If adjustments are needed, they're fed back into the system immediately. One of the most impressive aspects of this stage is how it balances scale with subtlety. Producing vegan pork at 50,000 pounds a day could easily flatten nuance, turning food into a generic commodity. Instead, the process is designed to preserve small variations that make food feel real. Slight differences in strand thickness, gentle irregularity in seasoning distribution, and natural clustering of fibers all contribute to a more authentic result. Perfection here is not sameness, but controlled imperfection. Fat integration deserves special attention. In animal pork, fat is interwoven with muscle, melting during cooking to baste the meat from within. Recreating this effect with plants requires precision. Plant-based fats are introduced at specific points so they adhere to fibers rather than pooling. During heating, these fats migrate and settle, mimicking marbling. When the final product hits a hot pan, these fats melt and sizzle, carrying flavor and creating the auditory cues people associate with cooking meat. This stage also defines how the vegan pork will behave in different recipes. Whether it's destined for tacos, barbecue sandwiches, or stir fries, the product must absorb sauces without falling apart. The flavor infusion and texture setting process ensures that the fibers remain open enough to soak up liquids while staying resilient under heat. This balance is tested repeatedly, often by simulating real cooking conditions directly in the quality lab. Beyond taste and texture, there's a psychological element at play. The hypnotic precision of the process builds trust. Consumers may never see these machines in action, but they feel the result when the product performs reliably every time. It pulls apart the same way, browns the same way, and carries flavor the same way. Consistency builds confidence, and confidence turns first-time buyers into regular users. At this point, the shredded jackfruit has fully crossed the line from raw ingredient to finished protein base. It's no longer just structurally similar to pork. It behaves like it in the kitchen and satisfies the same expectations on the plate. All of this is achieved without animal inputs, without excessive additives, and without sacrificing the sensory qualities that make food enjoyable. This phase represents the soul of modern vegan pork production. It's where engineering meets culinary art, where data supports instinct rather than replacing it. The hypnotic motion of mixers and the quiet precision of sensors may feel cold on the surface, but their purpose is deeply human: to create food that comforts, satisfies, and fits seamlessly into everyday life. By the time the product leaves this stage, it carries more than flavor. It carries intention, proof that plant-based food can be crafted with the same care and complexity as traditional meat, even at massive scale. The fibers are seasoned, structured, and ready, waiting only for packaging and distribution. What started as fruit is now something entirely different, shaped by technology but grounded in nature, and poised to redefine what people expect from vegan pork. Beyond the machines, the shredded fibers, and the hypnotic precision of production, this entire operation represents something much larger than a single food product. It offers a clear glimpse into the future of sustainable protein production, a future where scale, efficiency, and environmental responsibility are not competing goals, but interconnected ones. Inside this fully automated jackfruit facility, every decision is shaped by the idea that feeding a growing global population does not have to come at the expense of the planet. At the core of this system is efficiency by design. Producing 50,000 pounds of vegan pork per day might sound resource-intensive, but when compared to traditional animal agriculture, the contrast is dramatic. Jackfruit grows on trees, requires no feed crops, and produces high yields per plant. There are no emissions from livestock digestion, no antibiotics, and no long growth cycles measured in years. The raw ingredient arrives already rich in usable biomass, allowing the factory to convert a large percentage of each fruit into edible product. This efficiency reduces land use, water consumption, and overall environmental strain. Automation plays a central role in making this model scalable. From the moment jackfruit enters the plant, human handling is minimized. This is not about removing people from the process, but about using technology where it excels. Machines perform repetitive, precision-critical tasks with consistency that human labor alone cannot sustain at this scale. In return, workers focus on oversight, quality assurance, and system optimization. The result is safer working conditions, reduced contamination risk, and a production line that runs smoothly around the clock. Food safety and traceability are built directly into the system. Every batch of vegan pork is digitally tracked from arrival to packaging. Sensors log temperatures, moisture levels, processing times, and ingredient ratios in real time. If an issue were ever detected, the system could isolate affected batches within minutes. This level of control is difficult to achieve in decentralized, animal-based supply chains, where variables such as animal health, feed quality, and transport conditions enter layers of unpredictability. Waste reduction is another defining feature of this future-focused model. Jackfruit is large, but very little of it is truly wasted. Skins, cores, and seeds are separated cleanly and redirected into secondary uses rather than discarded. Some become ingredients in other food products, others are processed into agricultural inputs or industrial materials. By designing the plant as part of a broader ecosystem rather than a standalone facility, the operation moves closer to a circular economy, one where outputs from one process become inputs for another. Energy efficiency is also woven into the plant's design. Heat generated during shredding and steam treatment is captured and reused where possible. Water from washing stages is filtered, treated, and recycled, reducing overall consumption. Even lighting and climate control are optimized to minimize energy draw without compromising safety or performance. These details may seem small individually, but at industrial scale, they add up to substantial reductions in environmental impact. Perhaps the most significant shift this facility represents is cultural rather than technical. Vegan pork made from jackfruit is not positioned as a compromise or a niche alternative. It is designed to fit seamlessly into existing food systems. It cooks like meat, absorbs flavor like meat, and satisfies the same culinary roles. This lowers the barrier for adoption. Consumers do not need to change how they cook or eat, they simply change the ingredient. That subtle shift is powerful, because widespread change rarely comes from radical lifestyle overhauls. It comes from familiar experiences made better. The reliability of automated production also opens doors for global distribution. Consistent texture, flavor, and safety standards mean the product can travel across borders without losing identity. Restaurants, food manufacturers, and home cooks can all rely on the same performance, regardless of location. This kind of dependability is essential for plant-based proteins to move from trend to staple. Importantly, this model does not reject tradition, it builds on it. Jackfruit has been used in savory dishes for generations in many cultures. What's new is the scale and precision with which it's now processed. By combining traditional ingredients with modern engineering, the plant bridges past and future, proving that innovation doesn't always require inventing something entirely new. In the end, this facility offers a tangible vision of how food production can evolve. It shows that sustainability is not about sacrifice, but about smarter systems. It demonstrates